This is lesson 51 for anyone that missed it or needs to rewatch it. Go ahead and pause the video if you want to do it on your own or follow along. Find the missing part to make each equation true. So we're using what we understand of exponents, and I always ask students to come up. So we get m to the fourth times m to the negative seventh. What is that equal to? Well, the rule is if we're multiplying by the same base, we multiply any coefficients. 1 times 1 is 1, and then add exponents. So 4 plus negative 7, we get m to the negative third. Awesome. Number 2, we have c to the eighth over c to the something equals c to the sixth. So what's the question mark here, right? And a student said 2, and I'll say, yeah, how did you get that the question mark equals 2 for number 2? And they said, because you have to do 8 minus the question mark equals c to the sixth, so it has to be 2, because 8 minus 2 is 6, so 2. Fantastic. And how about the last one? If we have c to the fourth times c to the what equals c to the fourth, again, the rule is keep the base the same and add the exponents. What's the only thing that the question mark could be? Well, it has to be 0, because c to the 0 times c to the fourth is c to the fourth. Great. Hope that went well for you. So we're coming back from thinking about, oh, no, sorry. Just to recap, we kind of have some notes here. So 2 to the negative fourth, we proved, is 1 over 16, which equals 1 over 2 times 2 times 2 times 2, which is 1 over 2 to the fourth. So the general rule, again, is any base to the negative power, we're going to write it as 1 over the base as a positive power. So 5 to the negative third is 1 over 5 to the third. Negative 3 to the negative fourth is 1 over, keep the base the same, make our exponent positive, but put it underneath the fraction. And so we also hinted at this idea of the opposite rule, right? If you have 1 over 2 to the fourth, you can move it up and say that that is 2 to the negative fourth. So if we have 1 over a to the b, that's the same as saying a to the negative b power. Oh, okay. So it's sometimes useful to turn positive exponent form that are in the denominator as to its negative form in the numerator. So 1 over y to the second is keep our base and make our exponent negative. And 1 over 10 squared, take our base, since we have a positive exponent in here, we're going to write it as a negative exponent, like so. Okay. Great. And so then I wanted to give you some practice to do this. I think everyone would be pretty good. I'm going to just put the answers down, but if you had questions, you could bring it up in class. Notice that I don't change the base. I only change the exponent to its positive form in the denominator, because that's what it means. That's what we discovered. Boom. And then going the opposite, we can do it too. 1 over 8 squared is 8 to the negative 2. And 1 over 10 to the fifth is 10 to the negative fifth. 1 over 2 to the third is 2 to the negative third. 1 over 6 to the seventh is 6 to the negative seventh. keep the base the same, right, over denominator exponent, and then move it up as a negative exponent. Cool. And so that repetitive motion is just to get us to think about it, just keep pushing ourselves. So those are the answers to classwork 2. Okay, kind of an important moment, which is kind of annoying. Mathematicians throw this word simplifying around a lot, if you know what I mean. And simplifying has so much stuff, right? When we ask to simplify something, it can mean one of 100 things, or just wrapped into the same exact thing multiple times, right? Simplifying can mean a lot, but in the end, we're trying to make it as simple as possible. So mathematicians do not want to see any negative exponents or zero exponents in a fully simplified expression. So all bases with negative exponent must be in their positive form, and bases with a zero exponent must simplify out to be the number 1. So 10 to the negative 4th is not simplified. We have to write it as 1 over t to the 4th. 3r to the negative 5th, well, 3 has an exponent of 1 times r to the negative 5th. So 3 is actually okay, but it's r to the negative 5th. We have to write as 1 over r to the 5th. And this isn't simplified because we can multiply this across. 3 times 1 is 3. 1 times r to the 5th is r to the 5th. Now we're simplified. Even in this one, let's try this one. It's x times y to the 3rd times 1 over z to the 5th. But we can simplify this a little bit more. And this would be great if you got it, but we're going to go straight across. X, y to the 3rd 1 is 1x y to the 3rd over 1 times z to the 5th is 1 z to the 5th. To be honest, we don't need these ones. Okay. All right, let's keep going. Let's give this a try. 8 to the 0, that's equal to 1. So this is equal to 1/3. This one, we can't have a negative exponent. So we're going to write as 1 over x to the 3rd over y to the 5th. But we have an issue. This isn't simplified. Mathematicians don't like to see a fraction on top of another part of a fraction. So to resolve that, we need to do 1 over x to the 3rd divided by y to the 5th, which is 1 over x to the 3rd times the reciprocal, which is 1 over x to the 3rd y to the 5th. But you can kind of look for a shortcut, right? Forget all that stuff. Is there a way to go from here to here? Notice where y to the 5th started. Where did it stay? Notice where x to the negative 3rd started and where it ended up as x to the 3rd. Okay, we're going to try to use a little pattern here. We're not going to write out all our steps. You could write this as 2 times 1 over x to the 3rd times 1 over y to the 2nd over z to the 4th and do a bunch. But I have a different approach that I want you to take. Negative exponents will end up moving their location. So 2 is a positive exponent. It's fine where it is. X to the negative 3rd is not. It will become 1 over x to the 3rd. And what will happen is it will drop to the denominator. It was in the numerator. It will drop to the denominator. Y to the negative 2nd is 1 over y to the 2nd. And so it turns y to the 2nd into the denominator. See? Z to the 4th is fine where it is. It's just z to the 4th because it doesn't have a negative exponent. And there we go. So look where we started. Look at the math that we kind of would have to do and look at our answer. All right, so I want you to give this a try, right? So simplify these, okay? You can't have zeros or negative exponents in your final answer using some of our rules. Pause me now. Give it a try. Then you can watch me as I write down the answers. Okay, I got the first 6 there. Maybe you had questions. You wanted to bring it into class. Okay, so there's the answers to classwork 1. They're a little bit tricky, that's okay. All right, we got to talk about this one more piece, and that's what happens if you have a negative exponent in the denominator. Well, we can't have one because it's not simplified if we do. So I'm going to write as 3 over 1 over y to the 5th. Yep, and there you go. No negative exponent. There's our answer. Except we cannot have a fraction within a fraction. It's not simplified. So if you do 3 divided by 1 over y to the 5th, which is keep, change, flip to answer. So you get 3y to the 5th. So there's a rule, though, instead of going through all of this, if you have a negative exponent in the denominator, you write it as 1, and this is going to move up to the numerator, keep the base the same, and make it a positive. Right, and technically there's a 1 in front of the a, so if you wanted 1 over 1, but in the end it's just a over b. So let's apply that to some of these guys. All right, number 1. Okay, you could write it as s to the 6th over 1 over r to the 3rd and do the math, or you could just simply know r to the negative 3rd, r to the 6th, excuse me, s to the 6th is going to stay where it is, and r to the negative 3rd is going to shift up to the numerator, put it over 1. That one stays where it is, and if you want, you just say 6s r to the 3rd. Sorry, s to the 6 r to the 3rd. All right, number 2. Can't have negative exponents, so we could write this as 1 over a to the 4th, 1 over b to the 9th, but that's just wonky. In the end, a becomes moves to the denominator, and b to the negative 9th moves up to the numerator as a positive 9. Because if you keep change flip, this is what you'll end up with. All right, another one here. Okay, we're going to simplify. J to the 5th is good. K to the negative 6 has to shift down as k to the 6th. J to the 2nd is fine where it is. K to the negative 4th has to move up. Oh, but maybe I shouldn't have done that, right? Maybe I should have done the math first. We have j to the 5 minus 2 times k to the negative 6 minus negative 4. Zoom that out for a second. Right. When you divide by the same base, you subtract the exponents. We get j to the 3rd times k to the negative 2, which becomes j to the 3rd over k to the 2nd. So I wanted you to practice this. I think this is to finish for homework. Remember, you can't have negative exponents. Think about our rules. We're going to get to the next one in a second. I guess we could do the answers. No, we won't. We'll pause.